Hi there, this is Algebra 1, Chapter 3, Section 4, Direct Variation. And I want you to just remind you that, well, not remind you, but kind of give you some, before we get started with the examples, some characteristics of what a direct variation is. It's important for you to realize that a direct variation equation is linear. It should look like a line, which we've been doing a lot in this chapter. But basically a direct variation equation always looks like this, y equals kx, provided that k is not equal to 0. So what is k? K is what we call the constant of variation. Sometimes we refer to it as the constant of proportionality. But more importantly for us, to kind of bridge the gap here, is that it's also known as basically the slope, okay? It's the slope of the line. So we've done slope in the previous section, so that's kind of where this comes right after it. A couple of other characteristics. The graph of a direct variation equation always passes through the origin. If the slope is positive, then k is greater than 0. Slope is negative if k is less than 0. All right, so I didn't draw a direct variation for you, but I can do that very quickly. Again, direct variation always passes through the origin like this. That would be a direct variation with a positive slope, and this would be a direct variation with a negative slope. Okay, so we're going to get to some examples here. Example 1 says, name the constant of variation for each equation, then find the slope of the line that passes through each pair of points. So you can see from the graph that we already know that the equation of the line is y equals negative 4x, and so k is negative 4. K is basically the slope, or the number that is in front of the x, so k equals negative 4. In the case of b, we have our equation over here for our line, y equals 1/2 x, and so in this case, k equals 1/2. So now, with the second part of what it asks us to do is to find the slope. So they've given us 2 points, and we already know what to do. We want to go x1, y1, x2, y2, and then find the slope. So my slope is going to be y2 is 0, minus y1, which is 4. Divide that by x2, which is 0, and subtract x1, which is negative 1, which means that I get negative 4 on top, and 0 minus negative is positive, so my slope is negative 4. And what we want to confirm here is that the constant of proportion, which was negative 4, is the same as the slope. That's supposed to happen if you do it correctly. So we'll come over here, we'll do that again. I'm going to go ahead and call this again x1, y1. This will be my x2, y2. So my slope will be y2, which is 3, minus y1, which is 0, divided by x2, which is 6, minus y1, which is 0 again. So I will get 3 over 6, which is in fact 1/2. And yet again, we can confirm that k is 1/2, which is the constant of variation, and also my slope was 1/2, and they're supposed to be the same. So now you can try this do-it-yourself number 1, and then we'll move on to another application. So in example 2, it's asking us to graph y equals negative 6x. And to do this, to graph any line, you have to have at least 2 points. But I want to show you kind of a quick way that you can graph it, because one thing that I mentioned earlier, and I hope you haven't forgotten, is that the graph of a direct variation equation always passes through the origin. And the origin has as a point 0, 0. Okay? So to graph this function, I already know that there's at least 1 point right here. And to graph a line, I just need an additional point, 1 additional point. To get the additional point, I'm actually going to use the concept of slope from before, which is that the slope, or k, is equal to negative 6. And because I know that in previous lessons we talked about slope being rise over run, I kind of want this to be a fraction. So I can make it a fraction by putting a 1 underneath, And now I can actually talk about rise versus run. Okay? So because it's a -6, it means that I'm going to go down. And because the 1 is positive, it means I'm going to go right. So I kind of want to tell you that right now. You can write this down. If the top number of the fraction is positive, it means you go up. If it's negative, it means you go down. And on the bottom, if you have a positive number on the bottom like we do, you're going to go to the right. And if you have a negative number on the bottom, you're going to go to the left. Okay? So right now, my slope is -6 over +1. The -6 tells me to go down 6 units, and the +1 tells me to go right 1 unit. So I am going to do that now. I'm going to start here at the origin, start at the point that I already have, and go down 6, 1, 2, 3, 4, 5, 6, and to the right 1. And I'll put my second dot there, and then I will connect the 2 dots, or points, and I get this line here. Very steep line there. And that is how you can graph a direct variation. Always using 0, 0 as one of your points, and then using the slope to get the second point. So now you can try these examples, and then we'll move on to our next application. So here we go. In example 3, we're actually going to write and solve a direct variation equation. So it says, suppose that y varies directly as x. And by the way, whenever you see this phrase, y varies directly as x, that is a huge indicator that you're going to have y equals kx. Alrighty? So that I already know, just from that sentence right there. And then it says that y equals 72 when x equals 8. So the problem here is that when it says in part A, write a direct variation equation that relates to x and y, I have to know what k is. And I don't know what k is, but I can solve for k because they've told me that y is 72. So in the place of y, I'm going to put 72. I don't know what k is. That's what I'm trying to solve for. And in the place of x, I'm going to put 8. Because they've told me that when y is 72, or when x is 8, y is 72. So now I just solve for k by dividing by 8. And it turns out that k is equal to, let's see here, 72 divided by 8, which is 9. So once I find my constant of variation, I can put it back into my equation, and I can give my final answer as y equals 9x. I'm really sorry about this, but it looks like my pen's battery is dying. So go ahead and write y equals 9x while I very quickly try to replace the battery here. And then hopefully we won't lose too much time. Okay, that's why it's getting very spotty there, because the battery was dying. So let's see if this will be better. There we go. Y equals 9x. So that would be my direct variation equation. In part B, it says use the direct variation equation to find x when y equals 63. So in the second part, they're telling me that y is 63. So we're going to replace y with 63. We know that k is 9, and we don't know what x is. So to solve for x, we're just going to divide by 9. And then we're going to get that x is equal to 4. Sorry, not 4, 7. I'm not exactly sure why I said 4. But there we go. We know that 63 divided by 9 is 7. So there you go. And that's how you do that. So we're going to let you try this little guy right here. Very similar question. And then we're going to do our last example. Let's change that page. Our last example here, which is example 4, and that is to estimate using direct variation. So it says here the distance a jet travels varies directly, and there's that phrase again, varies directly. So we have that distance varies directly as the hours, which is usually time. So in this case, they're telling us specifically in part A that they want distance to be called d. So instead of saying y equals kx, we're going to use d equals k, and they want time to be t. So an x is going to be a t instead of an x. But it's the same idea, so d equals kt. And then they tell me in the second sentence, a jet traveled 3,420 miles in 6 hours. Okay, so we already said that d is distance, so we're not going to put 6 in the distance, we're going to put 6 in the time. So we're going to put, we don't know what k is, and time is 6 hours. And then the distance is 3,420. So we solve for k by dividing by 6, and k is equal to 570. Once we know what k is, we can plug it back into our equation, and so our final answer for part A is d equals 570t. Okay? In part B, it says to graph the equation. So again, we already have a way to graph this, because we already know, because every direct variation always goes through 0, 0. We only need 2 points to graph this, so I can do 0, 0, and then of course I know that when x is 6, the y value is 3,420, because that was the information they gave us earlier. So now I have 2 points, and I can actually graph this, kind of sort of in a way here. I'm going to basically go 1, 2, 3, 4, 5, 6 on my t-axis. And for distance, I'm going to go by maybe thousands. So then we call that 1,000, maybe call this 2,000, call this 3,000. So 3,420 is a little bit above that. So to graph this little guy, I'm going to say that we have 0, 0 right there at the origin. And my second point will be 6 and 3,000, a little bit higher than 3,000, right about there. And then I'm just going to connect my 2 points. And that's my graph. That's roughly what this graph is going to look like. Okay, now we're going to go on to part C, where it says estimate how many hours, and again, hours is t. So when we ask a question, how many, that means that we don't know what t is. So we're going to be solving for t this time. Okay, how many hours it will take for an airliner to fly, and this is d. 6,500 miles is d. So in my equation, I'm going to replace the d with 6,500. And then I'm solving for t because I don't know how many hours. So I divide by 570. And then t is equal to 6,500 divided by 570, which is 11.4 roughly. So we're going to put an approximate symbol here. 11.4, oops, not t, 11.4 hours. All right? So that is how you do this little guide. So you're going to have one more example here. And then, by the way, this was in your book. It's Do It Yourself number 4. It's on page 184. I didn't include the actual diagram, but the only thing the diagram tells you that you need for the problem is that the air balloon, the hot air balloon, goes 350 feet, ascends 350 feet in 5 minutes. So aside from that, you don't need the rest of the diagram. So anyway, once you finish this do-it-yourself question, you will have completed your notes for this lesson, and I will see you in class. Thank you for watching.